Hello. Well, here's the homework that was assigned for over the weekend. I thought I would join you in the effort. Now, I wanted to review just for a second here the concepts that we learned about angles that are made inside of a circle, outside of a circle, or on a circle. In the first case here, we've studied central angles, and they're made by two chords, and the angle is equal to its intercepted arc. Inscribed angles have a vertex on the circle, and they are half their intercepted arc. That's review. If a circle has an angle outside created by a tangent and a secant, or perhaps two secants, then the angle that is created is equal to the difference between the two intercepted arcs. I'll say that again. If an angle is outside of the circle created by tangents, chords, or secants, then it is half the difference of the intercepted arcs. If an angle is inside created by tangents, by chords or secants, if an angle is created inside a circle, it is going to be worth half the sum of the intercepted arcs, and we made this in class. Here is an example of an exterior angle created by two secants, so it is half the difference. Outside is half the difference, inside is half the sum. Outside is half the difference. And if you have an angle created by a tangent and say a secant on the circle, then the angle is worth half its intercepted arc. This angle is half of this intercepted arc. Okay. Number one, we have an angle that's created on the inside of a circle by two chords. This angle is worth half the sum of these two arcs that it created. So that means that x is going to be half the sum. However, we don't have a right now on this circle, but we can find it. 80 plus 90 plus 140 taken from 360 will give us the measure of that arc. Remember, all the way around a circle is 360. So 140 plus 80 is 220. 220 plus 90 is 310. So A is equal to 50 degrees. Once we find A, we can find the measure of this angle. X is equal to 1/2 90 plus 50. 90 plus 50 is 140. 1/2 of that is 70, so X equals 70. Number two. This interior angle created by two chords will be half the sum of its intercepted arcs. Now we are given the angle, so now we'll need to find one of the arcs. 25 is equal to 1/2 the sum of 40 plus z. These are nice to solve by just multiplying everything by 2. So I'll multiply both sides by 2. This gives 50 equals the 2 and the half cancel. 50 equals 40 plus z. Subtract 40 from both sides gives z equals 10. And just to check, 10 plus 40 is 50, divided by 2 is 25. Number three. Here is an exterior angle. It is going to be half the difference of the intercepted arcs. So y is going to be equal to half the difference. Now I don't have the value for c yet, but I can find it. This arc right here is 110. This arc B is unknown. However, this arc is congruent to this arc, so this measure, 110, is also equal to B, which is 110. Congruent chords have congruent arcs. If I add 110 plus 110 plus 100 and take it from 360, I will know the measure of that arc because the entire circle is 360. So 110 plus 110 is 220, plus 100 is 320. 360 minus 320 is 40. So C is equal to 40. Now, to find the measure of the exterior angle, y equals 1/2 the difference of 100 minus 40. And notice again, I'm taking the bigger arc and subtracting the smaller arc to avoid negatives. It's the absolute value of the difference. 1/2 of 60 is 30, so y equals 30. Number 4. I have an exterior angle here of 25. It's going to be equal to the difference between D and 35 divided by 2. 25 equals 1/2 D minus 35. The difference between D and 35 divided by 2, which is the same thing as multiplying by 1/2. And that's equal to 25. Multiplying both sides by 2 gives 50 equals D minus 35. Adding 35 to both sides gives D equals 85. So D equals 85 degrees. 85 minus 35 is 50. Divided by 2 is 25. So the answer checks. Number 5. I'm asked to find E, which is part of this circle here, and then also find the exterior angle created by the tangent and the secant. I'll find this arc first. Well, again, 140 plus 160 plus whatever that measure is will equal 360. 140 plus 160 is 300. 360 minus 300 is 60. So this piece of the arc of the circle is 60. Well, the exterior angle created by this tangent and this secant is going to be equal to 1/2 the difference of 140 minus 60. 140 minus 60 is 80, times 1/2 is 40. W equals 40. Number 6. Here's an exterior angle created by two tangents. This angle is 50 degrees, and again, it's going to be equal to 1/2 the difference between its intercepted arcs, so G and F. We don't know what G and F are, but we do know something about these arcs. These tangents meet at points of tangency, and this circle has been divided. So if I were to give this value of the arc X, I know that the rest of the circle is 360 minus X. What I now have is an ability to write an equation with one variable. 50 is equal to 1/2 the difference of 360 minus X minus X. By assigning this arc's value X and knowing that this rest of the circle is going to be valued at 360 minus X, I can write my equation of 50, the exterior angle, equal to 1/2 of 360 minus X minus X, the difference of the two arcs. Simplifying this gives 50 equals 1/2 times 360 minus 2X. I'll multiply everything by 2, so I get 100 equals 360 minus 2X.